Uh, Guru sir, just an information like the presentation or talk will be recorded as per the ACT rules, sir, in order to upload for the YouTube.
No
Okay,
problem.
okay, sir. Can we start, sir?
Yeah, why not?
Welcome back, participants. We are honored today that we have Guru sir with us for this session. A small introduction with respect to Dr. D.S. Guru sir. Dr. D.S. Guru sir is presently serving as a professor in computer science, University of Mysore, India, and a senior research scientist on sabbatical at Naimo Technology Private Limited, Bangalore. He has more than 2.5 decades of teaching experience. Sir has served in several administrative positions such as Chairman, Administration Reformation Committee, University of Mysore, Chairman, Department of Studies in Computer Science, Mansa Gangotri, Mysuru, Director, Directory of Distance Education, University of Mysuru, and Sir is also a founder trustee of Maharaja Education Trustee, Mysuru, established various institutions in and around Mysore, including Engineering College, MIT Mysuru, and MIT Tandavpura. Sir has also rendered his service in a number of foreign institutes such as invited professor at USA, China, Russia, and France. Sir is fellow of Boycast, Department of Science and Technology, Government of India for the year 2005, recipient of an first ARP award under Engineering Science, Within Group of Science and Technology, Department of Science and Technology, Government of India, Government of Karnataka, India for the year 2010. On academic front, Sir has successfully guided 19 students and currently supervising 6 PhD students. Sir has published 80 plus journals and 280 plus conference paper, right now having H index 25 with 2,436 number of citations. Sir is also a member of advisory board program committees of IC DAR 2017, IC DAL 2018, and many more AI related conferences. There is an associated to a Journal of Pattern Recognition elsewhere, science, and serving as a reviewer for many journals. It's a privilege to welcome you for this FDP program, sir. Over to you, Guru, sir.
Thank you, Professor Rupa. Am I audible?
Yes, sir.
Okay. Share my screen. Is the screen visible?
Yes, sir.
What do you see on the screen now?
The presentations, the PPTs.
Sure.
Yes, sir.
Okay. So, good morning to all. It's another 15 minutes to say good afternoon, right? So, first of all, I thank and congratulate the organizers of this FDP for the benefit of faculty members, Madam Rupa and the supervisor, under supervisor Dr. Harish, who were instrumental in making this FDP possible today. My interest now is to highlight a couple of interesting avenues and touch upon the philosophical views on challenges related to such avenues for the budding technocrats or researchers to explore further various domains, various research contributions, keeping in mind how to make artificial intelligence or AI-based solutions really possible in real-time applications. Yeah, you attended for the last 5 to 6 days marathon lectures by eminent scholars. I'm sure that all of them have touched upon various applications, and while explaining their models, probably they must have also explained what are the other opening issues in the related applications for you people to consider and explore further. starting from the keynote lecture by Professor Nagbhushan till today morning session, probably by Dr. Kiranigi and Madam Shambhavi. You must have heard of that machine learning is an evergreen topic for researchers to explore further. I, being an old researcher, probably my interest is not to take you into too much of mathematical aspects or a solution to the known complex problems. However, as I am requested by the coordinator to only explore possible computer vision based applications for budding technocrats, budding researchers to pick up some good interesting problems to explore. At outside, perhaps when you look at the literature, and especially because of the existence of deep learning architectures today, it appears almost all of the problems have been well explored, and there is nothing like platform to further research. The only the developmental process which is supposed to be brought in. That's how we generally look at it. It's a kind of illusion that there are many interesting, whatever you feel and whatever you do from morning to evening, if every activity could be thought of as, could be considered for automation, perhaps. Even existing a powerful deep learning architectures, deep learning tools will not suit our requirement. So there is a big gap between what is being expected by the users and what is the status of the technology in providing us the solutions, right? And such gap has got to be identified clearly. And any successful, a serious attempt bridging up such a gap existing between ability of the technology and the human user expectation could be a wonderful contribution to the society of artificial intelligence. So in the beginning of my talk, perhaps for about 5 to 10 minutes, I just focus my attention on science of machine learning, though most of the speakers have touched upon the issues, but for the sake of valedicting, concluding of this a week FDP program, I just focus my attention on the science of machine learning, and then subsequently quickly move on to a couple of interesting use cases which I happen to solve as a part of Nemo Technology Private Limited, working on sabbatical leave for the last 1 year. So you must have heard of many people starting from Professor Nagbhushan that what is intelligent computing, and so on. An ultimate job of a computer scientist or any machine learning person is somehow to make computers capable of understanding on their own and exhibiting certain intelligence, certain knowledge, the way in which we exhibit. So if you look at these pictures, probably you can understand that no animal is used for general purpose, and every animal, starting from cow on the right top, or ox could be, and donkey in the left bottom, perhaps, if you see the dog, horse, right, in between. Each of these animal is trained, has been given a powerful, training for a specific activity, not for a general purpose. So horse has been trained well for riding, and whereas donkeys were trained for carrying goods, and dogs were trained for security purpose, surveillance purpose on the other hand, right? And then the interesting thing that today we are talking about not to give a training for any animal which possesses natural intelligence, but to give a training for a system, a machine which does not exhibit any natural intelligence. So that's what is called artificial intelligence. Then computers were defined earlier as general purpose. Today we are going to see that the computers are not such general purpose, but they are personally tailored. So we are moving ahead of that and making our computers day by day smarter and smarter. So earlier our ancestors were talking about animals learning. Today we are talking about machine learning. That's the shifting technology. For these things, what is responsible is AI, artificial intelligence. So making computers exhibit intelligence, it is to program a computer. So when we started our bachelor's degree, I still remember that my teacher taught me a program of checking whether a given number is a prime or not, right? Even today, we teach our students, write a program to check if a given number is prime or not. No, I don't want any student to think of what is a prime number and explicitly program it so that the computer can decide whether that given number is prime or not. Instead, I'm looking for an environment where I just have some collection of only primes, which I have declared that these are some numbers of my interest called prime numbers. Could be 3, 11, 19, right, 31. I just have some randomly chosen prime numbers. And I have another subset of numbers which are composite, which are non-primes. I have some examples of non-primes. I have some examples of primes. If I just give both subsets of numbers into the system, I want system to automatically come out with its own program. The way in which I explicitly write a program, go on dividing it successfully in case if it is divisible by any other number other than 1 itself and declaring it as a prime, otherwise non-prime. Similar program has got to be generated automatically, or such knowledge has got to be built up automatically. Is there any way? So this is what we call it as a machine learning, right? So a step beyond AI is not explicit programming, but implicitly I expect that program to be generated, program to be developed automatically. That's what is to moving towards more personalized computing system. So then obviously we have samples to be understood, and samples have got to be learned, and learned knowledge has got to be reposited in a corpus, and that corpus will subsequently be used for the purpose of classification later. Then an unknown number is given. Then the question is to check whether that unknown number belongs to the first subset or the second subset, right? So this is what is called machine learning. It's an approach to achieve AI, learning to learn. It's not only learning something, it is how to learn. Understanding learning is what is called machine learning. So we talk about clustering problem, we talk about classification problem, we talk about prediction problem, but there I don't want to do any explicit programming. Without that, I want computer to come out with its own program. That's what is called specialized computing. So look at today, machine learning has made the specialized computing possible. So earlier general purpose, then moved on to personalized. Now personalized has been now into a specialized. Beyond personalized, what I want computing technology to be more specialized, working for a specific domain. And machine learning nowadays appear to be well-solved problem. It's an illusion on the other end, but because of the existence of deep learning architecture, a powerful teacher. Deep learning is today has become a model of choice for any researcher for that matter. But probably down the line in my lecture, you will notice that deep learning alone will not help you out in getting your solution integrated and making your solution possible to solve the problem in real-time applications. I'll come to that little later. Anyway, one thing is certain. Because of the existence of deep learning, the machine learning has become not so critical, has become possible today. So probably some of the speakers must have spoken about feature engineering, where you are responsible in identifying the suitable feature extraction mechanisms, or you can try out with possibly many feature extraction schemes and then going for dimensionality reduction, going for fusion of features, and then applying filter strategy. That's what is called feature engineering. You do analytics on the features. While you do the analytics on the features, then you may end up with a confusion. Which feature is really good for me? How do I selectively choose the best features to accomplish my task of my interest? Then you are responsible in feature engineering, and then going with a classification algorithm, a learning model perhaps, and then integrating these two, tying up these two together so that together will work for the problem. That's what is called classical machine learning, which you see at the top. So there is an input, and could be an image, could be an audio, could be a video, whatever it's so. There is something called an input, and then you have got to think of a suitable feature extraction mechanism. Then go for classification algorithm, could be a support vector machine, could be nearest neighbor algorithm, whatever it's so. And then tie up those two together. Once you tie up those two together, then you will get a solution to the problem. So this is our responsibility to tie up the best combination of these two, feature extraction and a class. And there are many feature extraction schemes, many feature different types of features are available, and there are many learning algorithms. Then which combination works best? This is how we used to work on earlier. Nowadays, what happens is, why can't we think of even feature extraction to be automatic, right? I want the system to learn the features also automatically, depending on the classification algorithm, right? Given is a classification algorithm, and given is an input and expected output, then what should be the best mapping? What is the best function which has got to be approximated so that all input image is correctly labeled? I don't want any human intervention. So user will never end up with any confusion. There shall not be any dilemma. So that's what is called a deep learning. Instead of learning at once, we at the different levels and start from learning from lower level features and then integrating lower level features through a method of assimilation, to a method of aggregation, so that you end up acquiring higher level knowledge, right? So moving from local to higher level, smaller low level to higher level, a local to global, or global down to local, so that my decision becomes most of the times correct, right? So then that's what is called a deep learning architecture. Probably the one who spoken out about deep learning must have touched upon what is the big difference between classical machine learning and a deep learning based machine. But one thing is certain, deep learning has become a powerful teacher for machine learning today. So with this background, if I just touch upon some basic fundamental setup of machine learning, then I would rather love to say that the machine learning task has basically 4 components. One is input space, call it as a sample space, where each sample is described by n number of features, right? An image of size 100 by 100. An image of size 100 pixels, rows and 100 pixels. It can be declared, can be described by 100 into 100, right? 100 into 100 number of pixel values. And that's what is called n. So n is the dimension. N is the dimension. So that dimension, a vector of features corresponding to the each sample in my domain, right? Domain may have k number of classes. Each class may have, let's say, m number of samples. Then you end up with k into m number of samples, where each sample is described by n number of features. That's what is called a sample space, input space. Then I have a label space, output space. For each sample, I expect label, maybe a positive, negative in case of 2 classes. Or it could be k number of classes, right? K number of classes. So class 1, class 2, class 3, etc. class k. Those are the labels here. I have a label space. Then there is a distribution, a mapping of input to output, and which generally the distribution is unknown. So that's the third component. So once I set up a system, the system may not give me what is really expected, exactly what is expected. It's approximation, right? And because of that, there is a loss function. I got to compromise with that loss, right? What should be that loss function? How do I declare that loss function? How do I estimate the loss function? Look, these are the basic 4 components of any machine learning. One is input, another one is output, and then the distribution of input mapping, input to output, and then a loss function. These 4 components. Then the task is, given are some examples of this mapping, right? X and a Y mapping. Given are some examples. I have some examples. And looking at those examples, I got to predict a better hypothesis, which will minimize this L, right? Which minimizes this loss function, right? Basically, it is a searching problem, right? In general, in computer science, or specifically in AI, what we are really doing is always a searching. It's a searching problem. Searching for what? Searching for the best effective hypothesis in the collection of hypotheses, right? There are many, many mappings from X to Y. Out of such mapping, possibly existing many mappings, which is the best mapping? I want some function which is supposed, which is expected to approximate in a better way, right? This input-output mapping such that the loss L will be minimum optimized. So then look at, this could be, this rectangular box could be a possible space where I got to search. This way I got to look for some hypothesis of my interest. That hypothesis could be this HG I'm looking for. HG is the most optimized hypothesis, which approximates most accurately this distribution from X to Y. But unfortunately, because most of the times I work with the parameters, and based on the parameters range, based on the values that I set up with the parameters, my search space could be only this, less than that. So H could be the search space. Most of the times I am restricted, myself to as possible minimum to that. So when I apply a searching algorithm, the searching algorithm may, come out with this. This is what is actually expected, right? This is what in this searching space, this is the most suitable, right? So that's what is called an approximation error. So the distance between this ground truth and expected is what is called the approximation error. Then it is, when you run your algorithm, when you implement it into it, you may end up with some computed hypothesis. This is what you arrive at through experimentation. Then I call it as a training error, right? So this somebody must have spoken about, overfitting, testing error and so on. These are the possible. But this is generally when I run in a specific environment of my interest, this is what is the output hypothesis. So then there is another error, right? So these errors have got to be minimized. And I am looking for some function f which approximates this distribution in a better way, such that these errors become as minimum as possible. It's basically a searching with optimization. So this is the fundamental, setup of any machine learning. In case of classical machine learning, we generally work in a Euclidean space, though human brain thinks in something which is non-Euclidean, but when we go for programming, we have to program it in a Euclidean space. And most of the times we try to achieve the decision boundary, assuming that the classes are linearly separable. Then I'm looking for some weight matrix, a matrix W. And this is X is an input vector, a feature vector. Upon multiplication, I expect this Y to be generated automatically. This multiplication of this matrix by a vector, this is what is called linear operation, right? Any operation which is realized by a matrix is called linear operation. So our classical machine learning always try to operate on the input space with the support of a matrix. Hence, it is a linear hypothesis. So we are looking for, in case of support vector machine, look at these are samples of one class, these are the samples of another class. I'm looking for a linear segment which separates, which separates these two classes in a 2D plane. Right? So it could be a decision tree ensemble, it could be a least square regression, whatever it's. So we always go with what? A linear hypothesis. But most of the times, the classes may not be linearly separable. In that case, we go for kernel functions. The kernel functions do not do what is called mapping of that non-linear distribution to a kind of linear separability, so that you can always think of a line segment separating these two. So look at here is an example. These two class samples of two different classes are not linearly separable, they are non-linearly separable. Then somehow work out a function phi, so that the moment you inject these as input to this phi will get them mapped placed in a different location, so that you can draw a linear segment separating two classes. This is moving from 2D to 2D itself. I mean, re-expressing the coordinates of these points, right, in 2D plane again. But on the other hand, look at this example. In this example, these red dots are supposed to be separated from these green dots. Then I do a kernel. What kind of kernel I am thinking of? I'm not going for reducing the dimension. Instead, I increase the dimension. I move from 2D to 3D. The moment I move from 2D to 3D, these red dots become somewhat separable from these green dots with the support of a diffusion surface. I can think of a linear diffusion surface here, hyperplane, for example, in general. Then I just project these red dots onto this vertical axis and these green dots also onto this vertical axis. Then I can put a threshold here in this axis, so that anything above the threshold is red, anything below that is a green line. So look at, finally I end up with only one feature, but initially I am with two features, but finally I end up with one feature. But that reduction 2 to 1 is not direct. That reduction is from 2 to 3 and then to 1. Sometimes, look, we recommend not to directly do the dimensional reduction, moving from n-dimensional space to some d-dimensional, where d is considerably less when compared to n. But we always recommend you move from n to m, where m is considerably higher than n, and then straight away reduce it to d, where d is negligibly small when compared to this n version. So that's what is the philosophy of kernel function, right? This is another example of kernel functions. I mean, kernel functions, most of the cases, what do is that they try to map n-dimensional vector onto some higher dimensional vector and subsequently reducing it to some other d-dimensional, where d is comparatively less than n. So in case of a deep learning, again, still deep learning strategy works in Euclidean space only, but here we try to approximate the separability with respect to nonlinear hypothesis. So it could be fully connected networks, it could be convolutional neural network, right? It could be a recurrent neural network where we are taking into account even temporal data. We have a gallery of deep technologies. Could be AlexNet, could be variants of ResNet, InceptionNet, GoogleNet, YOLO, SSD for detection, right? Object detection. There are many such, a gallery of deep topology. Existence of this gallery of deep topologies today has, made deep learning, the machine learning possible. So in deep learning, what do? We just integrate not only classification with feature extraction, but in classical machine learning, we do feature analytics separately and classification separately. Whereas in deep learning, we integrate both. So there shall not be any confusion. Your job is only feed the system what is a mapping, what input is mapped to what output. That's all what you have to do it. So what we learn is artificial intelligence and machine learning is a vehicle to achieve it, and deep learning is a powerful tool to make this machine learning possible. Look at deep learning is an algorithm which has no theoretical limitations of what it can learn. The more data you give, the more computation time that you can spend on, perhaps better would be the result. That's what Hinton says, right? I mean, deep learning requires a huge amount of data, and deep learning requires considerable amount of time for training the system. So hence, the opportunities could be many today, right? One is data quality. Yes, I get large amount of data, but are you sure the quality is acceptable? How do I clean? The data available is not necessarily structured, not necessarily cleaned, right? More time is spent on cleaning and preparing the data. Then can we automate that? Can we also think of a machine learning algorithm which supports me, right? Which supports me in cleaning up the data, improving the quality of the data available. Number two, because deep learning architecture requires huge amount of data. Where do I get the data? How do I get the data, right? How to make that available, right? So most of the times I'll have to get the real-time data, but real-time data is really tough to capture. So data labeling, yes. Even if you make it possible, to collect huge amount of data, then who would help you in labeling the data? Because you are basically a computer scientist. You may not be so good in understanding the domain, medical data. Medical doctors are supposed to help us, domain experts. I want to work on some botanical, plant classification. Then there must be some botanist, who could help me out in labeling those samples which I collected. Though I put in physically great effort in collecting thousands of examples, but unfortunately I don't possess any domain expertise, then I cannot label them. Without labeling the data, I cannot feed into the deep learning architecture. Then how do I catch hold of the domain experts? How do I see that they are also with the similar interests so that they support me, right? That's another big issue today. So data explainability, right? Which features are good? Are you sure that you are not biased by labeling the data? How do you make sure of that? What is the privacy, right? Confidentiality of your data, right? You just log into your Facebook and you give some data, right? You capture a picture where you are along with your good, friend, but that you put it on the Facebook. Then what is the guarantee of confidentiality of the data, right? Nobody assures that that person has not used your photography for training his own deep learning architecture, right? So building a trust. So look at AI lies on technology, but people do not trust it. How to convince the people, citizens? Investment. Who will invest? Because technology is really expensive. So these are all issues, challenges. Then how to address all these, right? And keep in mind, it's not that we are always thinking of something which complements every action, but it is supplementary too, right? We'll have to convince the people. I'm working on AI solutions. Oh, AI solution for what? Number plate recognition. Then police people should not always, depend on your system telling that whatever the system has declared is a correct number. We are just assisting the police people. We are just assisting with the support of a, tool, a medical doctor. That doesn't mean that our tool would be replacing the doctor, right? It's only a supplementary, right? Not a complementary technology. High expectations. Yes, that's what I'm telling indirectly, that people are expecting, right? Very high from us, from a technologist. So There are many challenges. There are many opportunities. If you keep your problem on the shoulder, it appears to be a problem, but you have to somehow keep it down so that you can walk on that. Then that problem becomes an opportunity. It's in your hand. Dear friends, remember that most of the tasks do not require deep learning. Probably some of the speakers must have narrated wonderfully well about the strength of deep learning, right? The strength of deep learning. I do agree that deep learning has made machine learning today realizable to the extent, but most of the tasks do not require such effort. Even simple classical machine learning algorithm, classical learning algorithm would serve the purpose. Most of the times, the moment we take up some problem today, it has become an interest of a researcher always to look for some deep learning algorithm, not necessarily. There is nothing like fully automated. Keep in mind, semi-automation is possible. All models which are existing are not true. Though some are useful, I agree, but not all of them are true, acceptable. And faithfulness and outcome of AI tool, that's what is called explainable AI. What is explainable AI? Simple task. Let me put it in 1 or 2 sentences without taking up much time. So here is a deep architecture. This is so capable. It has been trained well, and now it has become capable of generating the class label. Given is a face biometric of a person, then it declares that it is Mr. X. If Mr. Y comes in here, then it says Mr. Y. I'm sure that. I'm very happy that it is 100% success. Yes, it has no error at all. Then one day it simply says that, right? When a person X is here, then it says X. Then the question is, should I just simply blindly believe it? Just because it has been validated in an experimental laboratory environment, after 1 or 2 days, should I continue believing it, right? What is the guarantee that after 2 days, it will never go wrong? How do I believe it? Or I just want to know, suppose there is an X-ray, chest X-ray of a patient is given, then the system declares that it is a COVID-19 chest X-ray. Then we are going to hospitalize that person. Then should I simply believe that just because my deep learning architecture has declared that it is a chest X-ray of COVID-19? What has made this deep learning architecture to come out with such a decision? On the other hand, if a doctor declares, looking at the chest X-ray, if a doctor declares that it is COVID-19 infected, then we will have a second simple direct question. Sir, how do you declare that? What has really made you to think that it is infected chest X-ray? Then doctor would explain us, right? Look at, these are the spots where these are all the things, because of the presence of these, spots, I declare that it is not conventional, right? It is not conventional, viral infected or bacteria infected, but it is, COVID-19 infected. Then doctor would explain us. Can we think of a parallel deep learning architecture? A parallel deep learning architecture, which is capable of tapping out at different levels of this existing deep learning architecture, so that because of it taps it up at multiple levels and it assimilates the tapped information, so that it will not only just end up declaring the result, it also reason out the result, right? Why this deep learning, the first deep learning, has made up such a decision? What is the reason for it? Can such explanation be generated? That is what is called explainable AI. I want another AI. I want another deep learning model working on existing deep learning model, not supporting it, but reasoning it out. While one deep learning is reasoning, while one deep learning is learning and making up a decision, I want another deep learning model to watch it and carefully tap them intermediate results. And based on the assimilation of the intermediate knowledge generated, I want the second deep learning architecture giving me a paragraph explanation about why the first deep learning has made such a decision. That what we call it is AI with AI. It is another branch in machine learning today, especially in deep learning, a branch of deep learning called explainable AI. So that's a wonderful research topic for you people to explore further. And any simple attempt towards proposal of such a architecture, parallel architecture for generating explanation could be considerable reward. So opportunities and challenges due to COVID-19, suddenly it has appeared, and most of the technological solutions went wrong, and then reinvention and reprogramming of machine learning tools happened for the last 6 months. If I just share my own experience with you people, we deployed as a part of NIMO technology in Singapore, we deployed powerful face recognition system in the month of, in the end of last December and in the beginning of January 2020. But in the month of March, though the system was 100% accurate, working on roughly about 2,000 employees of an organization, but in the month of March, that in the 3rd to 4th week of March, the system used to go wrong because suddenly people started appearing in front of the camera with masks because of the COVID-19. So then, look at here is, the system was trained without mask, but the people started appearing with mask. Then the system is expected to continue working fine, recognizing people without making any wrong decision. But unfortunately not possible, right? Then what we thought of is, we anyway extracted some 128 features applying deep learning architecture. And can we selectively choose? I mean, we went for what is called dimensionality reduction. I just wanted to see applying some filter mechanism. Somebody must have quoted, somebody must have explained a day before yesterday. So 128 features, which are these features, out of 120, which of those features are responsible only for eye area? Can I figure out only such features which are responsible for representing eye area and a forehead area? So I can neglect these mouth area, features representing mouth area, so that instead of working with 128 features, I can work with less number of features, still accomplishing a recognition, right? That's what was the problem we faced. Then attempted with different strategies, and then somehow we could tackle it, right? So first of all, we are going to decide whether that person is with a mask or without a mask. If without a mask, then go for direct matching. If it is with a mask, then do a filtering of features and then go for matching with a subset of the features. So these are some results we just have explored for mask detection, for mask classification, right? Worked on about 2,150 subjects, and then with some examples with mask, with some examples without mask, and then tried with many deep learning, different deep learning architectures with different training testing ratios. These are some results quoted. So feature subsetting, what we have. So look at here, the system was trained with this full face, but at the time of recognition, this person has come with a mask. Only this is visible. I mean, partial knowledge is available, not fully data, right? So this person, partial data. Sometimes the system was trained for a full face, very clean. But this, even if the person comes with some beard and spectacle, system used to work fine. But on the other hand, the moment the person started appearing with mask, suddenly the system went wrong. That was the problem. Then we explored subsetting methodologies and somehow could fix up the problem up to 92%, if I remember. And later on, we just finally, while people were coming in, though the system used to go wrong, but those system used to, system was given additional samples of face images with mask, and then automatically retrained, got the system retrained, relearned, and corpus knowledge base, refined. And now the system works for whether person comes with a mask or without mask, irrespective of it. The system is now working 100% fine. This is how one has to explore. So I mean, what I want is, indirectly I am conveying is that it's not that your responsibility is to somehow set up a machine learning algorithm to solve the problem. Instead, if I ask a person to do that job, don't think that that person learns automatically and changes his knowledge base according to the situation. Similarly, I want a dynamic machine learning algorithm, right? The dynamic machine learning algorithm is the one which looks at the environment. If there is change in the environment, automatically it also adopts a related knowledge in the library, so that from tomorrow onward, the system will work fine, right? So that's what is called dynamic machine learning. Algorithm is another hot area in machine learning, a dynamic classification algorithm, right? Almost all classification algorithms are static. Almost all classification algorithms are parametric, right? I want some, learning model which is non-parametric and a dynamic in nature, right? So feature selection, look, so if I quote an example, it's 173 and 173 images were the example with mask and without mask, 128 features, and system used to work with 81%, right? And when we tried with the different, feature selection mechanisms, feature strategies, and then fusion of those ranking strategies, then we could achieve 92%, right? So this is basically on dimensional reduction, especially on feature subsetting filters. So they can think of, sir, if instead of going for a subsetting, why can't we extract only this and feed into a feature extraction mechanism, deep learning, let another 128 features to be extracted. Now I have two different vectors of dimension 128. One is for the entire face, one is for only the top area of the face. If a person comes with a mask, then go with this. If a person comes without mask, go with this, right? You can think of, that's what is called, instead of working with a feature subsetting, you can go for convolutional neural, or you can take 128 from here and 128 append some another CNN, so that the CNN responsibility is to convert this 128 original into another, let's say 64, and this 120 features extracted from a face image with a mask driven to another 64, so that this 64 would have eye match, right? So we can think of tagging up or appending one more CNN at the next level also. So these are the ways in which you can take up your research further and further, so that it suits the real environment. So it's a more come out with a model and then running it in offline and quoting result, it's a different scenario. But seeing that it is deployable in real-time application is really challenging. Look, when I was working for my PhD, I worked only on 9 industrial objects, stating that it is a big problem. But today, even if you go with 9,000 industrial objects, that's not a big problem. Scalability is a question, right? Scalability is a question, right? So that's what is called regenerating two types of encoding and then mapping them into a similar encoding. So that could be a wonderful research opening. Some more, if I touch upon selectively choosing the best views for a real-time face recognition, gender classification in real time, so that could be an added attribute for near search applications. And expression identification can be exploited for online classes today. Can we think of? All of you are logged into the system, and I doubt, almost everybody is listening my lecture. What is accountability? How do I take care of your attendance? In an offline classroom, conventional classroom, the speaker will monitor. A teacher monitors the students attending the classes, but in online, how do I monitor? What is the guarantee that you are listening my lecture, right? Look at here, a very serious student, sincere student attends my lecture, but on the other hand, look at this student. This participant sleeps well, but keeps the system on, but muted both speaker and a video. Muted. I cannot watch. I cannot see whether it is alert or not. But can I think of always keeping the camera of the system on without bringing it to the notice of the participant? And camera should not send me complete video, so that one has got to, Dr. Harish or Dr. Rupa has got to sit and watch every individual video and make sure that everybody is alert throughout 1 hour of lecture. No, I want edge computing. What is edge computing? Edge computing is the one which is deployed on the specific computer, and before it sends any information to the organizer, it has to do on its own, making up some decision, verifying whether the person is alert or not. If not alert, then only information has got to be sent, not the video data. So can we exploit the beauty of edge computing to make sure that the participants are attending the lecture without missing, right? So that's what is a real requirement today. So we can, online classes, we are moving from conventional to online classes. Then the problem now is with attendance, making sure that the participants are alert and attending the lecture fully to issue the certificates, right? Then you can think of computer vision based edge computing technology. So all 100 participants' video should not be sent to the organizers. Instead, in the respect to computers, in the respect to mobile cell phone, somebody may be just listening my lecture in the mobile cell phone. See that the computer, camera of that mobile is on and continuously capturing and looking at my face. If I am understanding it, my facial expression is different. If I find it very difficult to listen to the speaker, then my facial expression is totally different. Then in 1 hour of lecture, I want to know out of 100 participants, how many have really enjoyed my lecture, how many went sleep, how many really found it very difficult to follow my lecture. If anybody is in between found, finding it very difficult, can I, repeat my lecture with a different example, the way in which I do in a conventional classroom, right? I look at the student, facial expression, I understand that boy is finding it very difficult to follow me, then I don't think that I go with a different example. Can such information be automatically generated and sent it across a network so that it gets displayed on the monitor on my screen, so that I can watch and repeat with a different example? So this is an interesting opening issue for you people to explore, having attended this FDP program, having got some basic knowledge on conventional classification algorithms and then deep learning architectures. So this could be a wonderful, real challenging issue which we have been exploring. Okay. So somebody has visited my office at 9:30. He's not the man who, for who phase, the system has been trained. He's a new person, entered my office at 9:30 today. For some reason, he wanted to meet with me. He just stepped into my office, but I'm not available. Then he goes back, again comes back to my office at 11:21, right? Then the system has to understand that this is the person coming second time. System was not trained by using the face of this person. He's the new person entering into my office today in the morning at 9:30, but I was not available. Then again he came at 11 o'clock. Then the system has to tell me that, Dr. Guru, look at this man has come second time today, right? It's not that recognition of a person I'm talking about. Then his knowledge has got to be, the knowledge on that face has got to be reposited in the library of my model, but still I want. Don't you think that had there been my, personal secretary or my attender, standing nearby my office, he would say that, sir, he has come in the morning also, though this man is a new person, right? So though the system has not seen him so far, but has seen in the morning, it has to remember it. So then there could be thousands of people visiting my office. In case of a, grocery shop, how many people are old, the people who have visited my grocery shop yesterday, a month before, a year before, or how many are new customers to you? If there are some new customers, then I have to treat them separately so that I'll attract them also, right? So there could be some person who has been appointed as, some government office as a Tahsildar or a district commissioner, but he could be, some, royal customer for me. I have to treat him separately. Then his face photography is available on the web. Then the system has to download, and then the moment he steps into my office, my system should be able to say that so officer has stepped into your office, Dr. Guru. Please attend him, right? This is automatic. I want machine learning algorithm to be not simply mimicking, but somewhat to exhibit a kind of intelligence, the way in which we dynamically exhibit a day by day. So that could be an interesting problem. Then it's basically a hashing problem because of large, population, right? In a grocery shop, in any marketplace, in railway station, in bus station, right? Who is a old passenger, who is repeatedly coming every day, right? So can we classify the people based on that? So this is into social distance violation because of COVID-19, right? So we tried with some, drone cameras. This is a picture of Bangalore city. Please watch this. We have gone with a drone camera. We have taken the license and permission to fly the drone camera and captured this, and then implemented distance computation algorithm. Then check if there are a crowd of people violating social distance. If so, alert can be generated, and so on, right? So this is a real bottleneck problem today, especially in Mysore city, because of COVID-19 is increasing like anything. Can we think of exploiting the beauty of machine learning algorithms so that we can monitor people moving around, Mysore city, so that we can give them some alert that be careful, right? So something like that. So this is some more YouTube available video which we have taken up to test our hypothesis, right? To test our model. Look at here is a crowd detected, crowd dispersed, and so on. This is real-time working. These are the models working in real-time applications, crowd dispersed, and so on. Okay. So internally we exploited the beauty of clustering algorithms, and then YOLO-based, SSD-based, person detection algorithm. And then once persons have been identified, then we calculate the mutual distances, and then deployed a hierarchical clustering algorithm with a dynamic threshold value, so that automatically the system will cut the dendrogram and decide whether it's a group of people violating the social distance or not. So many things were in. Look, no deep learning architecture alone would suit your requirement. I get to search for suitable deep learning architecture and then assimilate them, integrate them with an added knowledge. And that's what is called integrated solution. That's really challenging. cough detection, right? While walking on the road, somebody coughs, then you can give him an alert. Be careful, and please see that you voluntarily home quarantined, and so on. So other challenges, like what I already explained. But look at here, there is an entry activity. Somebody is entering my office. People are walking out of my act. This is an activity called entry activity. This is an activity called exit activity. How do I differentiate? Very simple. The problem is like this. You collect some photographies or some video shot where people are entering. You take up the photography in your own home itself, main door. People are entering into house. Capture some video shots. And see that people are walking out of your residence. Capture some video shot. Now I want you to come out with a solution to differentiate these two activities, so that when an unknown shot is given, the system should be able to say that it is an entry activity, it is an exit activity. Then temporal information has got to be taken into account. Then use your conventional CNN, extract the features, use your fully connected network, and generate the labels for different instances of this entry and different instances of this exit, right? And take them in sequence, give them into a finite automata. Can that finite automata be automated with the support of recurrence neural network, RNN, right? Temporal information. At an interval time 0, door is closed, person is somewhere else here. At an interval time 1, T1, door is slightly open, person is moved. This is an exit. So on the other end, this is an entry. So you can differentiate these two with the support of sequence. Can that sequence be learned automatically with the support of RNN? Then it's a combination of convolutional neural network, fully connected network, and then finally, subsequently with the RNN, right? So this is how you have to tackle the problem. Such an integration of suitable architectures is really required. Then you have to search for it. Again, it is a dilemma. It's a confusion for you people. That's where we look for research. See, here is people playing, shuttlecock, and there are some activities. Look at the system has identified that something went wrong. He has fallen down, and people gathered together. Crowd detection. Look here, you can see at the top left, crowd detected, and he is taken care. Right? This is a crowd detection in a sport environment. Okay. See, here is a person walking without playing but disturbing others, right? Some person is disturbing. This person is known for disturbing people. That's the problem, right? Look at that person. Then the system has to inform the owner of this court, owner of this auditorium, telling that there is somebody who is not, given any permission, but he is disturbing others playing, and somebody is trying to intentionally, hide the camera view, right? Hide the camera view. That you can notice. Okay, sometimes we keep our kerchief on the camera because we don't want camera to be watching us. Then intentionally we do it. Then the system has to understand that somebody is hiding me. The moment it understands that somebody is hiding me, then alert should be generated and sent it across so that one can come and rectify the problem. So personal equipment, protective equipment detection. So look, this is a really working area, very dangerous. Then people are expected to go, workers are expected to go with helmets and jackets. If anybody walks in without helmet, then that person should be given a kind of alert. Right? This is a very dangerous zone. Then person has got to be persons are blocked not to enter into this area, but if somebody enters, then alert should be generated. Such incidents has got to be identified, detected, and alert should be generated. Okay, so this is quite interesting application use case for you. Look at, probably I suggest you to concentrate here, a blue colored person who is trying to climb up now. Okay, see, assume that no other person is here watching, but he is alone doing his job. Then unfortunately, due to some reason, he falls down. When he falls down, if nobody is there, who will attend? Then the system has to understand that something went wrong, and then alert should be given to the owner of this construction land, and the owner can come and take care of him. Otherwise, had there been somebody, a kind of engineer who is watching him, climbing up and doing his job, probably he must have given him an instruction that be careful. I want system to understand before he falls down, before he falls down. I want the system to understand, right? Look, there is a possibility that he must be given a kind of instruction so that he will be very careful. That's what machine learning based algorithm is expected to do, right? So this is traffic in Bangalore city, right? So that in the morning, the vehicles are moving from city to industrial area. Very on the other side, look at traffic is not so dense. But here, deploying number plate recognition model, we are talking about it. Recognizing by human itself is very tough. But how do I recognize the number plates, right? Hello? Am I audible?
Yes, sir. Yes, sir. Clearly, sir.
Okay, something went wrong now. Something is wrong with the system. Oh my God. Okay. This is traffic of Bangalore city. See, here is working number plate system, ANPR, automatic number plate recognition. Can you see some of, I think you can see these numbers are recognized and displayed nearby, here. Okay, so this we have deployed in Bangalore traffic. Quite interesting and challenging job which we have done as a part of NIMO technology during my sabbatical period. So this is another interesting real-time application we worked on where we exploited the beauty of deep learning architecture. So here are the trucks passing through, then here are two gates, So before the truck pass through these gates, they are supposed to seek for a permission, and giving them a permission may take little time, and there will be because of that, there could be a queue of trucks. How many trucks are there waiting for entry in the queue? What is the queue length, right? What is their dwell time, waiting time, right? Okay, so then the problem when we tried with that, with the deep learning, the problems which we encounter are as follows. Look at, we are supposed to identify only those trucks passing through this lane, trying to pass through these gates, right? The system should never identify these vehicles. If you simply deploy a deep learning vehicle detection algorithm, it detects all vehicles in this environment. It detects all vehicles, but we don't want to detect all vehicles. Even if this vehicle should not be detected, look at, though it goes very close by, how do I avoid that? How to program a system, how to program a deep learning architecture to differentiate vehicles of my interest from the remaining vehicles. Even if there is a big truck pass through, we encountered this in real time, very difficult, challenging problem, and we took about 2.5 months to solve this problem. Okay, that red truck, went across. How do I differentiate, right? Then we just thought of specifying the zone of our interest and then identifying only the vehicles, then calculate the dwell time. Then look at, this is a vehicle ID number 2. Sometimes even when you initiate deep learning based, trackers, but trackers may lose sometimes because of sudden change in the environment, you may lose the trackers and you may have to reinitialize the tracker for the same vehicle. In such cases, a vehicle will be tracked by multiple trackers. Then how do I establish an equivalence, between trackers? So that's the real difficulty which we have. Till then, look at, this truck is not identified. Once it came into this zone only, it got detected. Now tracker is lost. Identify. See that tracker is lost. Here is ID 4 is generated. This is a 4th truck, right? But ID 8, same truck, different ID is generated because tracker is lost in between. That's the real scenario. Then what we want? We want this to be generated. ID number 0 is equivalent to ID number 1. The same truck was given 2 IDs. Same truck was given 3 IDs here. They were equivalent. And truck entered at this frame and exited at this frame, that frame difference, and divided by the number of frames per second captured by the video, that gives the dwell time. So this has got to be displayed. This should appear on my dashboard. This knowledge has got to be generated for every 1 hour interval, for every 30 minutes, right? Again, after every 6 hours, integrated, dashboard has got to be generated, and so on. This is what the problem we worked on. So there are many challenges, environmental conditions. So the system works fine when it is not a cloudy environment. If the system is, environment is cloudy, then system would go wrong. That's what we are facing today. So when rainy season started, the system started giving us some wrong result. We are working on that. So this is another interesting problem for people to take up as part of PhD, especially on, detecting, a face in a cartoon image, cartoon faces, right? Detecting face first. Once faces are detected, then who is he, who is she, right? What is the activity going on? Can we think of a machine learning algorithm to understand this cartoon? Look at who is here. You know the celebrity. Who is he? You know this celebrity. Who is he? You know this celebrity. Then what is this all together? What is the environment here, right? Can we generate that knowledge, right? So who is he, and so on. So I mean, celebrity recognition, not in original face image, but in a cartoon face, right? Cartoon face recognition, cartoon face classification, understanding cartoons. Those are really interesting new problems for machine learning people to work on, right? Ultimate. So first of all, and then what is the activity? Dancing, right? What is the activity? Dancing. What is this activity? What is he doing? Who is he? First of all, right? Where is the face? Recognizing, right? Another interesting is, look at this cartoon. Based on this cartoon, you search through the Google and retrieve the corresponding face image. Right? Given is a cartoon of Modi. Take up the Prime Minister Modi ji's cartoon. Given is a cartoon of Modi ji, and then as input to the system is expected to download all his photographies. Right? Can we think of such a retrieval, algorithm based on deep learning? Then single deep learning will not work. Deep learning with classical machine learning algorithms with added, models to make it much more intelligent. That is what is called total integrated solution. So cartoon face recognition. We also worked on gender classification. Now we are working on celebrity, face, cartoon face recognition, and so on. We have many, flora species, recognizing flora species, recognizing fruits, and then grading of fruits, post harvesting of management of fruits. That's quite interesting applications which we have been working on now in our laboratory. Ultimate, dear friends, see that whatever we are talking about has been a topic of discussion for the last 40 years, but still we are talking about that because the scalability is a question. Then can we think of some edge computing so that most of the tasks can be done in mobile devices? Feature extraction, feature engineering can be automated in the mobile device itself instead of transmitting it across, right? So any app which works on mobile device could be a wonderful technology today. So even at the time of recognition, you can think of edge computing in the mobile device itself before you fetch the data from the cloud and so on. So software development, if somebody loves to work on software engineering related problems, software engineering related problems, application to machine learning, that could be a wonderful bridge between software development and machine learning algorithms. So you can publish materials in software engineering journals also, if you are fascinated towards software engineering course. Okay, these are all application maintenance and user support maintenance systems. So this come all as a part of integrated models, right? So some research conducted could be flora species, fauna species in our laboratory, on object detection, created corpus of videos of various use cases, YouTube videos we worked on for object detection like person detection, human face detection, vehicle detection, activity like running, how do I differentiate running from walking, crowd formation, violence detection, and so on and so forth. Methods we have used are deep learning architectures such as SSD, YOLO, LSTM, etc. Right? So there are many interesting such problems which have been tackled for the last 40 years, but earlier we used to work on smaller data set. The frequency with which test samples used to appear was reasonably less. Now the frequency with which vehicle are moving is very high. Then recognition of number plate in such an environment has become tough. Then we have to go for high-end systems, not only high-end system, more efficient algorithms, right? One can work from hardware side, one can work from software side, right? So this is what is real challenging opportunities come avenues for budding technocrats to explore further. So in our laboratory called DAL, we have been working on these related, similar problems for the last roughly about 25 years. With this, if I sum up, hope I am on time at 12:45. So I just have touched upon fundamental science of AI, machine learning, and deep learning. Narrated some interesting challenges, issues with the example of face recognition applications, activity detection, and PPE, personal protective equipment and safety management system, ANPR, automatic number plate recognitions, and queue count in airport stage or in any campus like University of Mysore. There is or SJ College of Engineering. There is a big gate. There is a safe security guard who are checking every vehicle. At least now they are monitoring COVID-19, measuring the temperature. Then there will be a queue of vehicles. But earlier, 20 years back, there used to be only 2 to 3 cars, one by principal, one by director of the institute, one by maybe all HODs of 7 members. Perhaps per day, there used to be only 10 cars. But in SJ College itself now, every faculty member will have minimum 1 car. Minimum 1 car I'm talking about. And some faculty members will have multiple cars. They will come by 1 car in the morning, another car in the afternoon. Then the system will go fail, right? We'll have a confusion. So how to set up such a ANPR based person authentication, right? That's the real challenging issue today. So applications are many. So with this, if I stop without acknowledging the people, I feel my lecture would be incomplete. Let me thank wholeheartedly the organizers of this program for extending their invitation to be, for me to be here to share my bit experience with you people. Thank Dr. Harish, and special thanks to Madam Rupa and my research scholars and my research team in nanotechnology, who has given me some experience working on real-time applications so that today's presentation has become possible. I thank you one and all. Thank you very much for your patience listening with a reading of what is called Samshodhane in Kannada. ಸಂಯಮದಿಂದ ಕಲಿಕೆಯಲ್ಲಿ ತೊಡಗಿ ಶೋಭೆ ತರುವಂತಹ ಜ್ಞಾನರಚನೆ ಗಳಿಸಿ ಧನಾತ್ಮಕವಾದ ಯೋಚನಾ ಲಹರಿಯಲ್ಲಿ ಸಮಾಜವು ನೆನಪಿಸಿಕೊಳ್ಳುವ ಆವಿಷ್ಕಾರ ಮಾಡುವಂಥದ್ದು. Please build up such a patience and see that what you do it in a positive mind. Don't do it in a hurried way, and build up such great knowledge so that your juniors will remember you, not because of you, but because of your contribution to the research. With this small message to everyone, I thank you once again. Thank you very much.
Thank you, sir. Actually, it's a treat for us to always to listen to you, sir. And
Thank
we
you.
wholeheartedly thank you for giving such a wonderful philosophical aspects of machine learning things, sir. And you are always a role model and a mentor for all the activities we do.
Thank you.
Sir, we have a few questions. Can I?
Sure. Why not?
Yes, sir. So from Professor Sumana KR, Ma'am is asking, can you suggest the best suitable machine learning algorithm for classifying biomedical signals for drowsiness?
For drowsiness, what kind of data working on?
Biomedical signals, Ma'am is saying.
What kind of signals are those? Are they wavelengths? Are they frequencies, right?
Sumana,
How are those signals captured?
Sir, actually, we are talking on biomedical signals that are generated from sensors.
Okay. Now, which sensor is that?
That senses the BP variations.
Okay.
And
that's what I want. Is that a blood pressure signal
yes,
we are
sir.
getting?
Yes, sir. Yes,
Only
sir.
blood pressure or something different?
And even we are thinking
because
for,
drowsiness is not necessarily because of blood pressure.
Even for we are thinking for brain cells.
Correct. Yeah.
And these are the supporting sensors with which we want to ensure the person is drowsy or not.
Correct. Then perhaps you are going to go with RNN better.
Okay.
It's not that in a single time instant you are going to decide whether a person is experiencing drowsiness. It's because of the past 2 minutes data.
Yes, sir. Yes, sir.
Okay. I wish you go with RNN.
Okay. Sir, can you please suggest some of the resources actually from where URL that we can find it other than the hospital?
I wish you just drop me a mail. I will just get you some links and get you
Sure.
people connected also.
Sure, sir. Sure, sir. Thank
Sure,
you.
sure.
Thank you.
So we have one more question from Swapnil Shinde. I request Professor Swapnil to ask the question.
Hello, am I audible, sir?
Yes, certainly, please.
Yeah, sir, I would like to ask, what's the scope of face recognition technology 5 years from now, and
Okay.
is there
Actually, correct. So today everybody is hesitating touching fingerprint sensors because of COVID-19. So we are looking for biometric based authentication which is touchless. Okay, face recognition is one such biometric system which can authenticate people where person's biometric can be captured without even bringing into their notice, right? Obviously, down the line, for the next 5 years, you will have lot many scopes to build up systems based on face recognition.
Yes, sir.
But unfortunately, is not as powerful as fingerprint-based authentication. But we are working toward that. Even still, for all the corpus, some I think I have seen. Hello.
Yes, sir.
I wish others keep the mic muted, please. Okay, I wish remaining participants, please, I request you to keep your mic muted. Okay. So I recently had seen a research article in IEEE transactions where one team has published a paper on searching for face in 80 million faces in a gallery of 80 million faces, right? Unique face in a collection of 80 million individuals. Okay. So when you target, suppose if you are really fascinated towards working on face recognition related problems, don't go on only benchmarking, data set. See that you also come out with your own corpus, which is challenging and real time, and then solve the problem. There are many scopes for people to work further on face recognition.
Yes, sir, because I have read about many attacks which are there on this face recognition domain.
Correct. And nowadays we are preferring face recognition based system rather than going with any other like offline signature or online signature or fingerprint, because I want system something which doesn't require to touch it. Okay.
So means that's a good area where you can
certainly. Yes, certainly. Face recognition, attendance. Look at, even still in classroom environment, teacher will call every student to take up their attendance. Why can't you think of complete automated system which takes up the attendance without bringing it to the notice of student? And then also integrate with facial expressions to record, in addition to recognizing the face, and you can also record the information that the student has closed his eyes so many times in 1 hour and has slept for a while, right? And you can also classify the student, whether the student is really understanding the topic, though his cameras are on but CPU may be off.
Yes.
But teacher can notice it. Okay. Some students are keeping eyes on but nothing is going inside, but I notice it. I suddenly disturb him. So can camera help me out? Can camera generate such knowledge base? That's wonderful topic. Definitely you continue working on that.
Yeah, thank you so much, sir. Thank you for your answer. Thank you so much.
Sure.
So we have a question from HOD of CSE.
Of SAC?
Sir, actually, I think from MIT, sir, the name is not. Can I request HOD from CSE? The name is displaying so to ask the question. I think Deepu sir from MIT, sir.
MIT, Deepu. Yes, Dr. Deepu.
Hello, sir.
Yes, tell me.
It was an excellent session.
Thank you.
Thank you for your session. Sir, what are the standard data sets for video related videos?
There
For
are many,
example, like
depending on your requirement, depending on the problem that you are working on. There are many benchmarking data sets available, but I wish you should not focus your attention only on the data set available. Before you start your research, I mean, your means any student of you, think of some problem of your interest and then go for collectively, capturing videos, and then set up a system working for your real-time videos, and then for comparative analysis use the benchmarking data set. Okay.
right. Thank you, sir.
Yeah.
Sir, I have one question. As you know, I'm always keen towards the medical field. The case study, for example,
You are keen or you are forced to be keen by your husband?
then the same, sir.
Both are same. Okay.
So with respect to, like, if I take a case study like dry cough, sneeze, body pain, weakness, high fever, adding to it, difficult breathing. These are the rules.
You express it by some categorical labels, or
I've set the rule based and say it is a coronavirus. You are a COVID patient, something like that.
but not necessarily true, madam.
Yes. So how will the machine understand? Because doctors will be having the tactical knowledge, or because of some experience, or because of the case history. Because if it's an asthmatic,
correct. If you rule-based system or classical, they don't use any past history.
right, sir.
Deep learning is showing better performance because it is trained with many examples.
So all these examples will need to take care of all the
If
rules.
you want system to be more accurate, you'll have to train it with more examples.
As and when the new case, for example,
Rule-based system is system which does not exhibit any intelligence. Rule-based system is the one which does not possess any intelligence. Like mug-up, like a student is working for some calculations using what is that called as tables. You have 2 table, 3 table, no?
yes, sir.
Suppose I want to add 7 in 7, 7, 7, 10 times, no? Then look at the 7th table and the 10th row. That gives you 70. It's a lookup table. Suddenly, if I ask you what is 25 into 35, you cannot attend to that problem, right? Using lookup table.
Right.
Getting me?
Yes, sir. Yes.
Yeah. If you really want to address this problem of 25 into 35, then the one who possesses good mathematics would simply say that 25 is 30 minus 5, whereas 35 is 30 plus 5. Then it has become x plus a into x plus b, right?
Okay.
Or a plus b into a plus b into a minus b. That's the standard formula, right? A is 30, b is 5. So 30 minus 5 is 25. 30 plus 5 is 35. So 25 into 35 can be expressed as a plus b into a minus b, right? Then a square minus b square. 30 square minus 5 square. So 875. That's an intelligence, right? And that intelligence can be acquired only when you worked on multiple problems, many issues, many examples. Rule-based system will never suit your real requirement today for medical sciences, please.
Right, sir.
Rule-based system can help you out in reasoning to some extent. Hope you are
Thank
getting
you,
it.
sir. Thank you. Yes, sir. Yes, sir. Completely.
Yeah.
Thank you,
Yes.
sir. Dear participants, if you have any questions, you can drop in the chat box or you can ask directly to the sir. If not, so by your talk, we come to the end of this 5-day FDP program on CVPR, sir.
Oh, is it?
At
Okay.
yes, sir. At this context, I request you to give in concluding remarks to our
Okay.
participants.
Okay. Thank you.
Validatory kind, sir.
Thank you. Thank you very much. I really feel I'm honored and respected for having given me an opportunity to conclude this FDP. I really feel it's pleasure because I heard that my professor, my mentor, Professor Nagbhushan, has inaugurated and delivered a keynote, right?
Yes, sir. Yes, sir.
Yeah, so it's my pleasure to give a valedictory address for the function which has been inaugurated by my mentor, right? It's really a rare occasion for me. I feel it's my pleasure. And friends, you attended marathon lectures of many speakers for the last 5 to 6 days. You started on Monday, if I remember, right? For the last 5 days, you attended marathon lectures, and I'm sure all the speakers have not simply spoken out. Perhaps I believe that their experience has spoken out. Yeah, right. Whoever has delivered lecture, perhaps their experience has spoken out. Hope you enjoyed listening such lectures. And research is evergreen, and don't compromise for the qualities of the research, please. So especially in Indian scenario, we are most of the times hurry in completing our work rather than finishing our work with a great quality, right? So most of the times, we lose our patience in the last stage of our research, especially for the budding technocrats and including supervisors. I'm talking. Don't lose your patience in the last years of your research, because what is really important is the last few seconds while you are cooking your rice. If you lose your patience in the last few seconds, then that rice that you cook is not eatable properly. So if you really want to have enjoyable life, enjoyable research quality outcomes, don't lose your patience during the last stage of your research. Okay, don't look at the time, but better you look at the quality, maintain that quality, spirit of research, and then don't compare your work with any other. Go on your own domains and your own objectives, and set up your own goals, and see that you meet with your goals, if not today, day after tomorrow, right? So with that great patience, and attend through this type of marathon lectures. And I'm sure not all speakers are good listening, but they at least specify a couple of interesting tools, interesting data sets, could be interesting procedures, which will definitely catch you. So that make it a habit of attending through lectures of any speaker for that matter, and try to be you try to be a continuous learner. Researcher is supposed to be a learner, right? So this type of FDPs, I'm sure, would definitely help you a lot. And organizing this 5 days event is not that a easy job. This SJ College of Engineering team headed by Dr. Harish and Rupa has really put in great effort to make this event possible for all of our benefits. There is always a scope to explore. And actually, if I share with you all, when I started my PhD working on object recognition, and when I used to explain other people that I'm working on some AI-based technology, actually during that time, especially in Indian scenario, people used to say that AI was a baseless course. Indeed, I did not take up AI as an elective course for my master's. But I did my PhD in AI related only. So because the people used to say that AI is something which is illusion. How can we expect computer one day becoming capable of mimicking our knowledge? So the people used to laugh at me working on this problem, but today the people are fascinated toward this problem, right? People, because ultimate job is the way in which our ancestors got the animals trained so that to make their life comfortable. Today, we cannot depend on another person. We cannot depend on an animal. Can we depend on something which is under our control, called the one which does not exhibit any natural intelligence? That's what is called computers. So training computers so that we will have our life in a better way, so that we feel comfortable. If not to replace anybody, at least to supplement everybody, to support. So it is a kind of supplementary tool, machine learning. Don't carry that, we are looking for completely replacing personality, but only a supplementary tool, right? So with this small message to all of you, I wish you grand success, and I wish to see you all at higher heights in futures in your future career, future endeavor. Best of luck to you all. And congratulations to all the members of this organizing committee of this 5 days FTP program. Congratulations to you. You really deserve a big applause, but through online we cannot give because everybody has muted their mic. Please feel pleasure that you made the event possible. Congratulations to you. Thank you one and all. Thanks a lot.
Thank you, sir. Thank you for valuable time for engaging with our participants, sir. Thanks a lot, sir.